Good morning. Good morning. Well, that is, of course, unless you're watching this in the evening or afternoon, in which case, how do you do? We are going to continue the June 2016 Common Core Regents exams. We already did questions 1 through 8 in a previous video. We are now going to do problems 9 through 17. And what a great problem to start with. It's a data or a stats problem, and this is one of the last units that we did before we started to review. So this works out great. In fact, this was one of the problems we had in one of our lessons. Okay, let's read number 9. The heights of women in the United States are normally distributed with a mean of 64, a standard deviation of 2.75 inches. The percent of women whose heights are between 64 and 69.5 inches to the nearest whole percent is, okay, this screams normal CDF. Normal CDF. Yep, that's an M, which would be NOR. Oh, look at how I save that. Normal CDF right in the calculator. This is a 100% calculator problem. How do I know that? They're asking me for a percent. They're giving me a lower bound, and they're giving me an upper bound. They also give me the mean and the standard deviation. And those 4 pieces of information, okay, the lower bound, the upper bound, the mean, and the standard deviation are exactly the 4 pieces of information I need to put in the calculator to get the percent. Okay, so I'm going to open up my calculator here. Now, let's not forget, who can remember how I access normal CDF? Well, that is a function or a calculation for distribution, data, stats, and above vars in blue is an abbreviation for distribution. So I'm going to hit second, vars, and I'm going to pick number 2. I'm going to clear that out. My lower bound is 64. My upper bound is 69.5, 69.5. My mean is 64. All right, so that is 64. And my standard deviation is 2.75. 2.75. Ooh, delete, 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 delete. Always make sure. Always look up and check things in the calculator before you do them, because a lot of times kids will miss simple calculator problems because of typos, myself included sometimes. So I hit enter and I paste that into the function and I hit enter one more time. Bang. So 2 enters. All right. So if I did that right, okay, the probability is 0.4772. If I turn that into a percent, I saw that twice. So I got 47.72%. And if I round that to the nearest whole percent, that will round up to 48. Bam. Beautiful. Great way to start. That indeed is the answer. Number 10. The formula below can be used to model which scenario? So they give me some information here. Okay, this has to do with sequences. More specifically, that is a recursive sequence because they actually give me A1, which is the first value. All right. Do I really need to understand that to answer this problem? No, I don't. What I need to understand, you know what? I think it'd be better if I read all the possible responses and then told you what I need to understand. Nah, screw it. I'm going to tell you what you need to understand now. Look it. What I need to understand is the following. Oh, my highlighter friend. I'm going to take A minus 1. That means I take the previous term, okay, and I multiply it by 0.80. I know for a fact that this is going to be a decreasing function. What does that mean? If I start with 3,000, okay, A2 is basically taking the previous number, okay, if this is 3,000, taking the previous number, A1, and multiplying it by 0.80. So that's 3,000 times 0.80. And if I did that right, okay, that would be 2,400. All right, and it would be. So what does that tell me? All right. That tells me that as I move ahead, I am only maintaining 80% of what I had. So I keep 80%, and my decay, I'm decaying 20%, right? 0.20. So I keep 80%, I lose or decay 20%. That's what this whole sequence is doing to me, okay? Or to the situation. Not to me. I hope I'm not decaying 20%. I'm already 5'8". I know. My voice makes you seem like I'm a strapping 6'4", but I'm not. I tell people I'm 5'9" because I'm really 5'8" and like a quarter. Because I figure, yeah, I'm past 5'8". So maybe I'll just say 5'9". But anyways, let's take a look at our answers here. One, the first row of a stadium has 3,000 seats, and each row thereafter has 80 more seats. That would be increasing if it has 80 more. This is definitely decreasing. Okay, it has a decay of 20%. It is not number one. Number two, the last row of a stadium has 30 seats, and each row before it has 80 fewer seats. Okay, that means I would be decreasing by an amount of 80. This, from 3,000 to 2,400, is decreasing by 600. It is not decreasing by the number 80. So it is not that one. Okay? Number three, a bank account starts with a deposit of 3,000. Okay, this looks promising. And each year it grows by 80%. No, we know this is decay. It does not grow. The answer is 4, because let me explain it. Even if I didn't do this by process of elimination, the reason it is number 4 is the following. Number 4 says the initial value of a specialty toy is $3,000, and its value each of the following year is 20% less. That means it is decaying by 20%. Even though it doesn't say anything about 0.80 or 80%, it mentions the decay, 20%. See what they did there? Try and throw you a little screwball. A lot of people notice that the right answer had 20 in it. All 3 of the wrong answers had an 80 in it. And look, the 80's right here. So they really try and bait you. They try and trick you into picking the ones that have 80. But no, what they give you isn't the percent you keep. What they give you in the right answer is the percent you lose. Those sons of guns. Sons of guns. Okay, on to the next one. Number 11, Sean's team has a baseball game tomorrow. He pitches 50% of the games. There is a 40% chance of rain during the game tomorrow. If the probability that it rains, given that Sean pitches, is 40%, it can be concluded, that these two events are independent, dependent, mutually exclusive complements. Complements just means they're like opposites. Like if it rains is 40%, not raining would be 60%. Okay, so that's this here. Mutually exclusive, I don't even know if I can teach that. It's crazy. It looks like that's just a made up thing. I know it's not those two. 99% of the time, when they ask you a question, and these 4 are the possible solutions, it's either going to be independent or not independent, which means dependent. So it's either going to be dependent or independent. Again, dependent means not independent. Okay, I'm not going to spell that whole thing out. So look what they give us. All right, Sean's team is a baseball game tomorrow. He pitches 50% of the games. So I'm going to say Sean pitching is 50%. Okay, there's a 40% chance of rain. So I'm going to say rain is 40%. Okay, and the probability that it rains given that Sean pitches is 40%. So rain, remember this little bar means given. Sean pitches, that's also 40%. So there is a really, really, really easy way to figure out if something's independent or not based on what they gave us. Now, what we need to do is the following. If rain given, I used an S for Sean pitches. I should have put an S here for Sean then. Okay. Equals point, you know what? If this equals just rain, they're independent. So let me explain. This 0.40. This 0.40. They're the same, so they are independent. Let me explain. If the probability that it rains is 40%, if the probability that it rains given Sean pitches is 40%, it doesn't matter if they give you Sean pitches or not. They're the same. Rain is going to be the same no matter whether it has something else here or it doesn't. That completely is the explanation behind independence. R is independent of everything else. It doesn't matter if we have Sean pitching or not. Rain is still 40%. Rain is a bad boy. He's independent. He's a loner. Okay, all the girls try and tame him and bring him down and change him. But that Rain, he can't be changed. He's awesome. He's what every man aspires to be and what every girl wants to date. No, I'm just kidding. I'm going off on a tangent. It's independent. Numero 12. Number 12. A solution of the equation 2x squared plus 3x plus 2 equals 0 is. Multiple ways to do this. Number 1, I can graph this parabola, and wherever it touches the x-axis is a solution. However, it might be irrational. Might get some run-on decimal. You might get just 0.5. That's a half. But if the answer is imaginary, that is not going to show it touching the graph at all. And you know what? If I do graph this, if I graph this, it would look something like this. It would not touch at all. Okay? So it can't have a real thing. It's got to be imaginary if it doesn't touch at all. But now, how do I know which one of those it is? Okay? We're going to have to do this algebraically. Now, if you didn't know the graphing way, and again, the graphing way only eliminates 2 of these answers for you. Okay? I could use the calculator, and I could take, let's say, 1/2 and plug that in for x. Okay, and if I plug in 1/2 for this and hit enter, and if it equals 0, well, that's an answer. 1/2 won't work. Neither will this. Look it, there's actually an I button in the calculator. I could type this in, but be careful. I have to put this in parentheses. That's a lot to type in. But I could put it in for here, and I could put it in for this x and see if it equals 0. And same thing, I would have to try this one. Okay? Now, if you don't have any idea on how to solve this, I would suggest you take the time and try just plugging this whole thing in for your x's and see if it works. If it does, that's your answer. If it doesn't, you try the next one. You plug this whole thing in. Now, if I was a plug and chug dude, and that's what I had to do to solve this, I would definitely start with the easiest one first. I would start by putting 0.5 in. Okay, and again, that's not going to be the answer. So I can't factor this simply. Okay, I have to use the quadratic formula. That's what we're going to do. Okay, in case you forgot, negative b plus or minus the square root b squared minus 4ac all over 2a. Now, where do my a, b, and c come from? They are the numbers in front of the variables. Okay, a is 2. A is not 2x squared. It's just 2. B is 3, and I got to, consider the sign. So B is actually a positive 3, and C is a positive 2. Let's plug these numbers in. I negate my B value, which is 3, plus or minus the square root of my B value, which is 3, squared, minus 4 times A, which is 2, times C, which is 2, all over 2 times A, which is 2. Keep in mind, anytime I am inputting a number for one of my variables here, anytime a number goes in for my B's or my A or my C, please notice I'm putting in parentheses, okay? If I had to type that in a calculator, that's exactly what I would do, okay? And you should get in that habit as well. So let's start simplifying this. That's negative 3 plus or minus the square root. Okay, 3 squared is 9 minus, 16. So that's negative 7. So this whole expression is negative 7. Okay, I know it's imaginary because I have a negative underneath the radical. Right now, I can confirm I need an I in my answer. Boom, that's a possibility, and that one is. Okay, I need because there's a negative under the radical. Bye-bye. See you later. Okay. All over, 2 times 2 is 4. Okay, that's not bad. Now, right now, before I do any other work, let me take it a step further, just for review. -3 plus or minus. The negative comes out and becomes an I, radical 7, all over 4. The radical 7 I can't simplify. It's going to be my answer. Right now, I know this has to be the answer because I have the radical 7. This does not have a radical. But let's finish this problem off. Let's finish simplifying this out. What they did here is they broke this up into 2 fractions. -3 over 4 plus or minus 1I over 4. Okay, then we have radical 7. And if I look at my answer, they actually put the 1 here, and they broke off the I radical 7 and just kind of left that hanging off to the side. So they have -3 over 4 plus or minus 1/4 I radical 7. That's exactly what the answer is. Now, you might be saying to yourself, Visca, this only has a plus. Okay, they're saying a solution. Like one of these is just one of the solutions. So they're just saying, really, I can have -3 over 4 plus 1/4 times I radical 7, or I can have -3 over 4 minus, that is a bad 4, 1/4 I radical 7. The plus is definitely one of the answers, okay? So don't freak out over that. The answer is choice 1. Oh, ho, ho, ho. Trigonometry rears its ugly head into our village. Number 13, the Ferris wheel at the landmark Navy Pier in Chicago takes 7 minutes to make one full rotation. The height, h, in feet above the ground of one of the 6-person cars can be modeled by the following. This is a height, right? Equals 70 sine of 2 pi over 7 times the difference of t minus 1.75, all plus 80, where t is time in minutes. Okay. Using h for one full rotation, the car's minimum height in feet is. You do not have to know anything about applying sine, cosine, tangent, whatever. You need to know the following, okay? This is the midline where I start. Okay, so I'm going to start, if I had a graph, right, I'm actually going to start at 80. That's my midline. Okay, this is my amplitude, 70. That means from my midline, I'm going to go up 70 and down 70. Okay, so if this is 80, 80 plus 70 here, this is actually going to be 150 max height. 80 minus 70 would be 10. So my Ferris wheel, the height of the Ferris wheel is going to be at the lowest 10, at the highest 150. You don't even have to draw this graph. Okay, you can just do 80 plus 70 and minus 70. So that goes from 150 to 10. Those are your min and maxes. They're saying, what's a cart's minimum height? 10. You had to know nothing about graphing, sine. You just had to know what's amplitude, which number it is. And in this case, your midline. That's your starting point. Okay, that's your middle. Okay, so if you're at 80, again, you go up 70 and down 70. Again, midline, amplitude. That's all you needed to know for this. If you could add and subtract, you got this problem. Easy. Number 14, the expression 4x cubed plus 5x plus 10 divided by 2x plus 3 is equivalent to what? Wow, this is from Unit 1. We are going to use reverse tabular division here to get an answer. Now, if you could not divide, whenever they ask you if expressions are the same, I could put this in graph for y1, and then I could try this for y2. If the graphs are the same, then the expressions are the same, and that would be your answer. If that isn't, then I would try putting this into y2 and seeing if that graph is the same as this one. So if the graphs are the same, okay, then they are equivalent. Okay, so there is a way to do this in the calculator, but you really should know how to do reverse tabular division. Okay, and that's what I'm going to do now. Because if this was a short answer where you didn't get any of these, you obviously couldn't put anything in the calculator, and you would actually have to divide that out. So that's what I'm going to show you right now. All right, the first thing I want to do is I want to make sure I'm not missing any terms. I am missing an x squared right here. So if I rewrite the top, technically it's 4x cubed plus 0x squareds plus 5x plus 10 divided by 2x plus 3. That's the first place they're trying to get you. All right? Now, next, seems like years ago, 2x plus 3 is what is being divided in. That is how tall this is going to be. But how wide? How many columns do I have? There's my 2 rows. Okay, this is what I do. All right, from every bottom corner, I write a term. 4x cubed comes out of here, 4x cubed. Out of this corner is my 0x squareds, 0x squareds. How many more terms do I have? 2. I have 2 more terms, so I need 2 vertical lines. 1, 2, because I need to create 2 more corners. Here's one corner I created where I get 5x. And here's my last corner where I get my 10. I always start top left. This has to be 4x cubed because that's what it outputs. What do I multiply 2 by to get 4x cubed? 2x squared. Now I can multiply 2x squared times 3 and get 6x squared. Here's the mistake everybody makes. You're going from multiplication to addition. These should add to give me 0x squareds. Just like this one was the only thing that gave me 4x cubed, these two should add to give me 5x. And last but not least, this one should give me 10. And if it doesn't, I will have a remainder. Okay? So what do I add to 6x squared to give me 0? A negative 6x squared. Now I'm back to multiplying. What do I multiply 2x by to get negative 6x squared? Minus 3x. Minus 3x times 3 gives me minus 9x. What do I add to a negative 9x to get 5x? 14x. All right. So far, so good. What do I multiply 2x by to get 14x? A positive 7. Okay, right now, this should be the first 3 terms in my solution. And right now, I only see one answer that has that. And I will finish this problem off. Positive 2x squared, positive 2x squared. Negative 3x, minus 3x. This one is a positive 3x. I don't want that. Plus 7, plus 7. My answer is the only one that has that is 2. But let's finish this problem off in case it was short answer. 7 times 3, 21. So I have a remainder. Okay? My remainder is this. How do I make 21 into 10? I need to subtract 11, don't I? That's my remainder. Minus 11. So my remainder, I put over what I divided in. I divided in a 2x plus 3. So minus 11 over 2x plus 3. This thing right here is my complete and beautiful answer, which is choice 2. Number 15, which function represents exponential decay? This is multiple choice. There's a couple ways you can do this. I can graph each one of those. Graph all 4 of those. If it is growth, not decay, growth looks like this, the graph. Okay, here's the x-axis, whatever, that's growth. If it's decay, it would be shrinking like this, okay? There's only one of them that's going to do that. The other 3 will all be going up, okay? I could do that. I could look at the graph. The second thing I could do is I could look at my table. I could put all those in y1, one at a time, and I could look at my table. If it is decay, your y value will be decreasing, meaning maybe it'll go to 10, 8, 5, 1, negative 2. This is decay. When y values decrease, it's decay. One of those will have your y values decreasing. The rest, they will increase. Okay? Growth would be 10, 15, 27, 39, and so forth. That's growth. All right? The way I tell my kids to check is the following. And I guess I would absolutely, yeah, this is a problem. Now I'm going to show you the algebraic way because they might ask you what the growth or decay would be if this were a short answer problem. Like they might give you this and say, is this problem growth or decay? Explain why. And I'm going to tell you that right now. In order to know growth or decay, I have some value in parentheses times my variable, okay, as an exponent, t. Right? If what's in here is bigger than 1, I will call this b, okay, because it's a times b to the t. If b is greater than 1, it's growth. If b is less than 1, it's decay. But the whole point is this has to be 1t. I can't have, like, for number 1, 0.3t. So I'm actually going to take my 0.3 and apply it to my 2. And whatever that is, see how the t is still on the outside by itself? That is the actual base. So I take 2 and I raise it to 0.3. That is actually 1.23, let's call it. So that's like 1.23 to the t. Again, let me explain that. I take 2 to 0.03 t exponent. I cut the t off so it is by itself. And when I put this in the calculator, I get 1.23. That is bigger than 1. So choice 1 is growth. All right? So that is not my answer. They want decay. Let's try number 2. I'm going to take my 3 and I'm going to apply it to 1.2 exponent. Okay, or excuse me, 1.2 to the 3, and I keep my t on the outside. So let's do that here. 1.2 raised to the 3. Well, I know that's going to be. It's 1.728. So 1.728. That is bigger than 1, so that's also growth. Kadoosh. Oh, interesting. This is like negative 1t. I want to take my negative 1 and apply it to 1/2. So I'm going to have 1/2 to the negative 1, okay, to the t. Let's see what that gives me. All right. So I'm going to take alpha y equals 1 over 2. Pop. Yep. Where's my 1? 1. And I'm going to raise that to the 1/2, okay? Or excuse me, to the negative 1. That's actually 2. Oh, didn't see that one coming, did you? 2 to, this is bigger than 1. This is growth. My answer has to be 4. And let's try that. Even though it's a whole number 5, that's like saying 5 to the negative 1t. I'm going to take my negative 1 and apply it to 5. Let's do that. 5 raised to the negative 1. Oh, that is 0.2. 0.2 to the t. That is definitely less than 1. That is my decay. All right? That is my decay. Love it. Good. Again, this is multiple choice. I could have graphed each one and seen which one increases. So why did I show you? They may ask you, what is this growth or decay, and what, by how much? What's the growth rate or whatever? It's decay. That's 1 minus 0.8 gives you 0.2. So it actually is decaying by 80%. They might ask you for that. That's why I showed this to you. All right, the last one today. I think I said earlier we were going to do 9 through 17, but 9 through 16 is going to give us our 8 problems, okay? Because we need to include 9. Sorry, oversight by math teacher. Yeah, I teach math. Anyways, given that f negative 1 of x equals negative 3/4 x plus 2, which equation represents f of x? This means inverse of x. Okay, inverse of the function f, I should say. Now, again from unit 1, if I have a function, how do I get the inverse? All I do is I switch x and y, and I solve for y again. Meaning, this is the same thing as like saying y. If you think about it, we have 2 variables. We have an x, so we have a y. All right, if I want to find the inverse, okay, or the original function from the inverse, okay, all I do is switch my x and y and solve for y again. I isolate y. Let me explain. If right now I have y equals negative 3/4 x plus 2, I am literally, quite literally, going to switch my x and y and then solve for y again. So I've got x equals negative 3/4 y plus 2. Let's take this and solve for y, and that will go back and forth between my original equation and my inverse. All right, so let's subtract 2. Subtract 2. We got x minus 2 equals y. All right, good deal. Oh, yeah, I'll be okay. Equals negative 3/4 y. Okay, so let's multiply all of this by 4, I guess. Actually, I'll multiply it by 4/3 negative. These cancel. I'll multiply this by negative 4/3. I'm going to distribute that to both terms. So I've got negative 3x. A negative times a negative will give me a positive. 4 times 2 is 8/3. This is my original equation to my inverse. All right, so which one is that? That looks like choice 2. That looks like choice 2. And it actually is. Beautiful. So when dealing between the regular original equation and its inverse, you literally just switch x and y and solve for y like we did. All right, that's the end of the second video, 9 through 16. When then we get together again, yeah, we're going to do 17, 18, 19, 20, 21, 22, 23, 24. Okay, we are going to do 17 through 24. That'll be nice. I'll see you there. I hope you join me. Peace out. Keep on studying. You're almost done. Success is right on the cusp. All you got to do is want it and study. By wanting it, I mean, like you actually put an effort and study. Want it, kids. Want it.